the showroom of an electronic equipment manufacturer in Kyoto. The company is a leading maker of train station operation systems in Japan. On display is a demo model that you can see inside of. Insert a ticket and look at it go.
こちらが初期型の自動改札機の搬送モジュールとなります。
Current models share this same core mechanism from 50 years ago. It's what sends the ticket through the machine. The device was recognized as an engineering milestone by the Institute of Electrical and Electronics Engineers based in the US. Our story begins in 1964. Japan was experiencing high economic growth. Housing developments appeared on the outskirts of cities, and the number of morning commuters greatly increased. The situation was of concern to a railway company in Osaka. Station workers stood amidst the throngs of commuters, checking tickets. The riders flashed their commuter passes. The staff would confirm the interval and validity of each pass, but it was a laborious task, which was a factor in the congestion at the stations. Could this check be automated? An electronics equipment manufacturer in Kyoto decided to take on the issue. At the company today is Hidaka Sushi, who is involved in the development of the automatic ticket gates. Here's what he heard about those times.
The engineers back then were also caught in that morning commute. Because they experienced the congestion firsthand themselves, they were motivated to try to do something about it.
A development team was quickly put in place. They headed for Osaka's largest train terminal. How many people arrived at the gate during the morning rush? The team counted 80 people in just 1 minute. From that, the goal was to create a machine that allowed 80 people per minute through without stopping. The team got to work immediately. The first issue was to find a way for the machine to verify commuter passes. The team had the idea to make the machine long. The pass would be inserted and travel 1.3 meters to the other side. That way, there would be time to verify the pass without stopping the flow. But how would the machine read the information from the commuter pass? Until then, station workers had visually checked the passes. They needed some way for the machine to do that instead. How could this be accomplished? The team searched for options. One day, they came across something. Teleprinters. An old way to send text messages. The devices read sequences of punched holes in paper for communication. The team could use the same kind of holes in the commuter passes. But things weren't so simple. During the morning rush, 80 people approached the gates per minute. In order for there to be no congestion, they set a goal of 0.6 seconds for sending a commuter pass through the machine. The team decided to use a conveyor belt, like the ones used in manufacturing. A narrow belt would be worked into the machine. The team tested their new conveyor belt. But the belt couldn't withstand the speeds and snapped. The developers kept on repeating tests. But each time the belt would snap.
When you run a belt at high speeds, it rapidly stretches and contracts. It's subject to a lot of force. After running it for 5 minutes, the belt would give out and tear apart.
For 2 months, the development team tested various kinds of materials for the belt. Finally, one day, they created a belt that could withstand the strain. The core mechanism for sending the pass-through was done. But there was nothing to prevent someone from just walking through the gate. The development team decided to add sensors to the machines. If a sensor detected someone coming through without a pass, the gates would close. This is footage of testing they did. 30 people were gathered, representing a variety of potential passengers. As the tests went on, they found a problem. If someone had a pass but was carrying a large object, the gates would snap shut. It seemed the sensors incorrectly picked up the large object as a person and closed the gates in response.
There definitely would be people passing through carrying large objects. So we had to carefully adjust the number of sensors and where the sensors were located.
After much testing, the team was able to find the right distribution of sensors and prevent false detections. The machine was ready to be installed. March 1967. The first automatic ticket gate would be set up at the station for a large housing development in the Osaka area. 7 a.m. The team members held their breath as they watched the morning rush commence. At first, things seemed to be going smoothly. But 1 hour in, an alert rang and the gates shut. The team opened up the machine to have a look. They found several crumpled tickets inside.
At that time, the machine was designed to handle commuter passes only. But after the rush hour, most people were using tickets rather than passes. Many didn't notice it was for commuter passes only and put their tickets in.
In order to keep things moving, the machine would need to accept tickets as well. But there was a problem. Tickets were much smaller than commuter passes. They wouldn't be able to punch holes in them for all the information. Was there a method that would work for tickets? One team member stumbled upon an idea. Magnetic storage used in cassette tapes. Music data was recorded on the magnetic material applied to the tape. The team prepared 3,000 magnetic tickets for testing. They inserted the tickets. And were able to read data off them. But then, the alert sounded and the gates shut. When they opened up the machine, they found a ticket that had gotten stuck at an angle. Since the tickets were smaller than passes, they could end up sideways or crooked inside the machine. How could they keep the tickets upright in the machine? The team searched for solutions. But they had no promising ideas. Then one day, one of the team members was out fishing in the river. As he watched the flow of the water, something caught his eye. A leaf. As it floated on the surface of the water, it ran into a rock, which spun it around.
The leaf rotated. It made the team member think of a ticket passing through the machine and getting spun around. The member latched onto that simple image and came up with a possible solution.
The team member got to work and added a roller at the front end of the machine. Hopefully, it would work like the rock in the river. If not, the team was out of ideas. Nervously, he sent a ticket through sideways. At the other end, the ticket came out upright. They put more tickets through sideways. Thanks to the roller, the tickets came out upright each time.
They finally were able to get all the tickets to go through upright and not jam. I think everyone felt a great sense of accomplishment. After all that hard work, they must have felt very fulfilled and satisfied with their accomplishment.
April 1971. The new automatic ticket gates were installed. Crowds of commuters passed through the gates without issue. A smooth start to the day.